Yes. Today we are going to discuss D'Alembert ratio test. Suppose that summation un, which is series of positive terms. What I am saying, summation un is, it is a series of positive terms. Then to check the nature of summation sn, that is to check the convergence and divergence, first we need to find limit value L, that is limit n tends to infinity un plus 1 by un. The nature of summation un, nature of series which is depending upon the limit value, where the limit value is limit n tends to infinite un plus 1 by un. That limit you have to calculate. In case L value less than 1, then we can say that summation un converges. And suppose the value of L more than 1, then we can say that summation un diverges. And whenever the limit value equal to 1, then the test fails. Nothing but summation un neither converges nor diverges. Okay? Nature we can't decide. The test fails. So that I am writing here, the test fails. We can't decide the convergency or the divergency of summation un. Let us see an example. Just remember that you have to calculate limit value for un plus 1 by un. This is the ratio. Okay? Limit n tends to infinite un plus 1 by un. Suppose less than 1 converges, remember more than 1 diverges. When L equal to 1, ratio test fails. I am going to choose an example. Suppose that the question is, test the convergency of summation n value from 1 to infinite, and the question suppose un is given as n by n power n. Here un is n divided by n power n. Okay, so that first I am going to write un value, that is n by n power n, and un plus 1 next I am going to write, that is n plus 1 divided by n plus 1 whole power n plus 1. Wherever n, there you have to write n plus 1. Okay. Now I am going to calculate limit value, that is limit n tends to infinity. By ratio test you need to find limit value as n tends to infinity to the ratio un plus 1 by un, right? So that L equal to limit n tends to infinity. What is un plus 1? Here you have, that is n plus 1 divided by n plus 1 power n plus 1. Next, divided by un. If I multiply, then that becomes just 1 by un. Here you are going to multiply. Here if I write multiplication, then that is what happens, n power n by n you will get n power n divided by n. Okay. Now limit value, limit n tends to infinity. I am going to simplify this. N plus 1 by n I am going to write separately. Next, n by n plus 1 whole to the power of n separately. Here n power n, and here n plus 1 whole power n only I am going to use. Remaining n plus 1 in the denominator part I am going to write. N plus 1 gets cancelled. Now L equal limit n tends to infinity. This is 1 by n. Next here it is n by n plus 1 whole power n. Okay. Now L equal to limit n tends to infinity. Here it is 1 by n as it is. Here n by n plus 1 you have. I am going to divide both numerator and denominator with n. When you divide with n, what happens? 1 by 1 plus 1 by n I can write whole to the power of n. In intermediate, you have the formula limit x tends to 0, 1 plus x whole power 1 by x. What you have? Limit x tends to 0, 1 plus x whole power 1 by x. This is equal to e. You know this. Suppose x equal to 1 by t. Then what happens? Limit t tends to infinity, 1 plus 1 by t whole power 2. This is e. Okay. So up to here it is e divided by n. Limit n tends to infinite. L equal to e by infinite become 0. Since the value of L less than 1 and hence summation union converges. Okay. This is the result. Next. Since less than 1, it converges. Okay. Next question. Another example. Yes. Any doubt? ఈ పార్ట్ అంతా రాలేదా? Okay. Yes. Next. Let us discuss another question. Test the convergency of summation n from 1 to infinite and the function un is n power 4 by n factorial. This is the question. By using ratio test, you have to decide whether it is converges or diverges. Okay. You know that it depends upon the value of L, where L is limit n tends to infinity un plus 1 divided by un. Okay. This is limit n tends to infinity. I am going to write first un plus 1. Actually, this part is un, right? Yes, un plus 1 in the numerator. That is n plus 1 whole power 4 divided by n plus 1 factorial. Next, un is in denominator part. When I multiply, it become n factorial by n power 4. Okay. Now, limit n tends to infinity. Here, n factorial and in the denominator part n plus 1 factorial, I am going to simplify. Numerator n factorial as it is. This n plus 1 whole factorial written as n plus 1 multiplied by n factorial. Okay. And the remaining part n plus 1 by n whole to the power of 4 it is. N factorial gets cancelled. And then limit n tends to infinity 1 by n plus 1 separately and limit n tends to infinity n plus 1 by n whole power 4 I am going to separate. This is clearly 1 by infinite become 0. Okay. And here as n tends to infinity, here in the numerator and denominator, if each term divided by n, then what happens? 1 plus 1 by n by 1 whole over 4. Now apply limit n tends to infinity. 1 by infinity becomes 0 here. 1 by 1 whole power 4. It gives the result 1. So 0 multiplied by 1 gives the result 0. L value we got 0. When L equal to 0, clearly it is less than 1 and hence summation un converges. Okay. So the nature of summation un converges. Okay. Let us move to another one. Next question. Very simple. Just you have to find the limit value as n tends to infinity un plus 1 by un. Depending upon the value of L, we can decide whether it is converges or diverges. Suppose L value less than 1 converges, L value more than 1 it diverges. If L equal to 1, then the test fails. Okay? Move to third question. Suppose that summation n from 1 to infinity un is given as n power 3 divided by 2 to the power of n. This is the question. Again, the aim is to find the limit value. As n tends to infinite, un plus 1 divided by un value. Let us find this. What is un plus 1? n plus 1 whole power 3 divided by 2 to the power of n plus 1. Next, un here in the, if I multiply, then it becomes 2 to the power of n divided by n power 3. Okay. What is 2 power n by 2 power n plus 1 value? 2 power n gets cancelled. What we get? 1 by 2 constant outside. Next, as n tends to infinity, this is n plus 1 by n whole cube, right? So n plus 1 by n whole cube. In the next step I am going to write next 1 by 2. Observe this, nn gets cancelled, 1 remaining 1 by n whole power 3, and here you have to apply limit n tends to infinite. So as n tends to infinity, what is 1 by n? 1 by infinity becomes 0. So 1 plus 0 whole power 3 become 1. 1 multiplied by 1 by 2 gives the result 1 by 2, and hence limit value is 1 by 2, which is less than 1. Therefore we can say that summation un converges. Less than 1, so that I am saying it is also converges. Okay. Next, one more question. Suppose that the question is summation n from 1 to infinite. In the numerator part, given that product of numbers 1, 2, 3 and so on n, and in the denominator part given that 3 multiplied by 5 multiplied by 7 and so on 2n plus 1. So this is the question. Both numerator and denominator you have product of so many numbers 1, 2, 3 and so on n. 3, 5, 7 and so on 2n plus 1 in the denominator part. Okay. Let us discuss this. Our aim is to find limit value as n tends to infinity. Using ratio test, we need to find un plus 1 by un, limit n tends to infinity value. So limit n tends to infinite, un plus 1 by un, it decides the nature of convergency or divergency. Yes. First, in the numerator, you need to write un plus 1. What is un plus 1? Actually, this is un, this part is. un plus 1 nothing but up to n plus 1 terms you have to select. So 1, 2, 3 and so on n, one more term n plus 1. In the denominator part 3, 5, 7 and so on. Wherever n, there you have to write n plus 1. So 2 times of n plus 1 plus 1. 2n plus 3 is the last term. After 2n plus 1, you need to write 2n plus 3. Next, actually you have to divide with un, right? But I am going to multiply. Nothing but I am going to write these sums in reverse. Reciprocal I am going to write 3, 5, 7 and so on 2n plus 1. Next 1, 2, 3 and so on n. Here 3 to 2n plus 1, 3 to 2n plus 1. Sequence of terms up to 2n plus 1 I am going to cancel. Next, here 1 to n and here 1 to n, product of terms, sequence of terms I am going to neglect. Then what remains? Only n plus 1 divided by 2n plus 3. And here you have to apply limit n tends to infinite. Okay. Now limit n tends to infinite, n plus 1 divided by 2n plus 3 you have. Suppose that if each and every term I am going to divide, if I divide with n, then what happens? This is 1 by n. I am dividing each and every term with n. Remember, 2 and then 3 by n. If I write directly n tends to infinity, it goes to infinite by infinite form. So that I am going to divide each and every term with n. Now apply n tends to infinity. 1 by n become 1 by infinity becomes 0. 3 by n reduces to 3 by infinity becomes 0. Therefore, what we get? 1 by 2. So that limit value L, which is 1 by 2 less than 1, this is also converges. Here? Okay. Next. Let us discuss another question. Very simple they are, is it? Suppose that the question is summation n from 1 to infinite n factorial whole square divided by n plus 1 factorial. This is the question. Okay. Yes. L, that is limit n tends to infinite un plus 1 divided by un by using ratio test. Limit n tends to infinity. What is un plus 1? Wherever n, there you have to write n plus 1 in this. So that it is n plus 1 factorial whole square divided by n plus 2 factorial. Okay, un plus 1 over. Next, you need to write un. Here, un is in denominator part, but I am going to write reciprocal of this by writing multiplication. So it becomes n plus 1 factorial divided by n factorial whole square. Is it? In the next step, limit n tends to infinite. N plus 1 factorial whole square is there. So n plus 1 factorial into n plus 1 factorial. Next, here you have n factorial. But I am going to write n factorial into n factorial. Next, remaining these two terms, n plus 1 factorial divided by n plus 2 whole factorial. Okay, yes, this is clearly n plus 1 factorial by n factorial value become n plus 1. Okay, and also here n plus 1. What about this n plus 1 factorial by n plus 2 factorial? In the denominator part, you will get n plus 2. Limit n tends to infinite. Okay. Now I am going to write limit n tends to infinite. This is n square plus 2n plus 1 whole divided by n plus 2. Now divide each and every term with n. Directly by writing n value infinite, we get infinite by infinite form. Okay, divide with n square. Why? Because highest exponent 2 you have here, higher degree 2. So I am dividing each and every term with n square. Now limit n tends to infinity. If I divide with n square, first term become 1. Next 2n by n square gives 2 by n. Next 1 by n square. And here n by n square become 1 by n. And then 2 by n square. As n tends to infinity, what happens? As n tends to infinity, this is 0 and this is 0 and here it is 1. So numerator 1. But in the denominator part, what happens? So 1 by 0, nothing but it approaches to infinite. So large number. Therefore, the value of L more than 1. When the value of limit value more than 1, then it diverges. So UN diverges. Here, this is about DLMS ratio test. Very simple. First, you have to write UN by the given question. And after that, you have to write UN plus 1. And then, by using DLMS ratio test, find the value of UN plus 1 by UN by applying limit n tends to infinity. Assume that limit value as L. Depending upon the value of L, you can decide the nature of the series. That is summation here. If L value more than 1, diverges, remember. If L value less than 1, it converges. If L equal to 1, the test fails. Okay? Enough.